The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to this week's edition of Boundaries Webinar Wednesdays. My name is Shei Shambore and I will be guiding you through today's webinar. We're just going to give it a couple more seconds here to allow a few other attendees to jump on before we get started. All right, we'll go ahead and get started. So again, good morning and welcome to this week's edition of Boundaries Webinar Wednesdays. My name is Shei Shambore and I will be taking you through today's webinar. Now, first off, just by way of, I guess you'd say, housekeeping, I'm going to point out a few things. First, everyone is muted on their computers, and so no one can speak to each other or to the staff over here presenting. If you have any questions, you can type them in the questions box of the GoToWebinar control panel, which should be a gray box on the right-hand side of your screen. You may have to click on a red arrow to pull it out, but you can type your questions in there. And we will, we'll get the questions, and we can go ahead and respond to those. All right. Next, other item in terms of housekeeping is that this session is going to be recorded, and the recording is going to be available after the webinar on our Boundary Systems YouTube channel. All right. So this is just going to be a fairly quick agenda of what we're going to go through. We're going to just do a quick introduction of boundary systems and who we are. We're going to talk a little bit about what Mathcad is, and specifically today what we're looking at, which is in this case the integration between Creo Parametric and Mathcad, why it's important, how it works. We'll talk about some use cases. And then we'll finally get into a live demonstration where we show you the software in action, and then we will we can have some time to answer some questions afterwards. All right, so just a quick thing about boundary systems and who we are. We are a product development consulting company based out of Cleveland, Ohio, but really we have a reach that's nationwide and even international. And we love to help our customers achieve higher levels of productivity and success when it comes to, product lifecycle or data management, CAD design or consulting, and also simulation as well. It really anywhere in the product development lifecycle where you have to use, a computer or, an iPad to either visualize or create a product or see manufacturing instructions, we have expertise, in the entire gamut, and we can help in every step of the way. All right, so fairly quickly, what is Mathcad? For those of you that may not be aware, Mathcad is a documentation and math processing engine that is developed by PTC, but really it allows very easy to follow communication, right? Because within Mathcad, for example, with the sheet on the right, you can create what's it called, math, right? Within the worksheet that Mathcad can calculate, right? You can also create in there formulas with variables and constants and calculus and all the complex math that as engineers that you need to do. But you can also combine that with very easy to use text areas so you can describe what your formulas are about or what's going on, right? You can also insert things like, pictures, right, as references, or, you could also attach documents and reports, right, or take screenshots of reference manuals and put them into the Mathcad worksheet. And then also what's not currently shown in here, Mathcad can also take in, huge matrices of data from either, spreadsheets or computer programs like Excel, or a data acquisition device as well that you're using in your testing. And you can then start to perform math, math operations on that data inside of Mathcad. And so really Mathcad is intended as a one-stop engineering communication document, right? So if you want to communicate to either your boss or your or one of your underlings, or the next person that's going to be in the job after you leave the company, what it is that you're thinking about when you created this particular design, what your engineering IP is, Mathcad is the way to go for documenting all of that out. All right, so why have the Mathcad and Creo integrated in this, sort of a newer way? Well, there are a few different reasons. One is that you get to, document design decisions and your design intent, right? And so you get to, something as simple as describing, based on your Creo model, what you were going through when you created that document or that Creo design, why you did things the way you did it, so that way any other customer, or I guess not customer, any other a colleague who inherits that document afterwards is able to follow a thought process and is not just trying to catch the wind and figure out what was going on, right? And sometimes it could be math related, like over here where you have some equations or formulas or constants that are calculating a certain value that's then going to drive your Creo model. Or other times it could just be, hey, I put this whole feature in Creo above this other extrude feature because of XYZ, right? And those kinds of things can sometimes be critical to transfer knowledge from one person to the other, right? Another example of why or I guess another use case of why Mathcad and Creo integration is so powerful, I sort of alluded to it earlier, is that you can do a lot of analysis-driven design, right? So, for example, in this case here, we have a whole bunch of, a range of values or constants where we want to, remain in between. But we don't know what the sweet spot for that, perfect radius or perfect, height of a particular dimension should be. And so we can then take all of that information, pull it into Mathcad, and then tell Mathcad, hey, grab the information of the geometry from Creo, run the calculations, tell us what the perfect number is, and then pass that number back into Creo, so that way Creo can regenerate the model to update as it should be, right? And so then you're performing analysis-driven design where, all of that, thought process into what's going on with your model dimensions is stored inside of Mathcad, right? And again, you can think of, the alternative, which would be, you taking a piece of pen and paper and writing out your calculations, calculating everything, and then you manually type in the number into the Creo design, right? Well, what happens when the design needs change? What happens when a customer says, hey, let's make this 2, 3, 5 inches bigger, right? What happens when you get a design change, right? And then you have to go update your calculations, right? All you have to do is, forget where you placed that sheet of paper, and you'll have to start from scratch, right? As compared to Mathcad, where in this case, the Mathcad document lives with the Creo file, and so it always remembers that associativity, and it can always, reuse that data in the analysis-driven design. All right, and then finally, the last use case that is really good with Mathcad integrated with Creo is you can also perform design validation as well, right? And so again, this is one where you want to be able to get a certain dimension or number that should be either greater than or less than a particular item, and with Mathcad, you can validate that, okay, yes, this, particular variable we have is within that range, or it'll tell you if it's out of that range. And so that way, you don't want to go put that, inside of your Creo model. And again, you can take, any, dimensions from your Creo model, pull them into Mathcad, and then you can start to run, I don't know, something as simple as, a beam deflection or bending analysis if you're designing a beam in Creo, right? To then validate that, okay, the size of your beam as modeled in Creo is going to, meet X, Y, or Z, parameters when it comes to the deflection that you're trying to achieve or something like that, right? And so you can also perform, design validation calculations inside of Mathcad and have that document live with the Creo model. All right, so at this point, we'll pause here and we'll switch to a demo of the software. So I will pause this here and we'll flip screens. We have certain, disks in here in the model that are supposed to, the more input torque you have to design for, in this case, the more disks you have to put in there in order to compensate and allow for effective stopping, right? And so we have in here, some the break geometry or dimensions for the break disk, and we know what the torque is going to be, and so based on that, we can then design the number of disks that should be there. And now you'll notice that there's applications in Mathcad button over there, and at the top of the ribbon, and you can either create a new worksheet or open an existing one, or you can insert an existing worksheet that's already been documented, right? So you can have a worksheet that your colleagues or you have already created, and you can just embed that into Creo, or in this case, you can start from scratch if you prefer it as well, right? The other thing to also note is that in this particular example here, so we've already loaded in this case a Mathcad worksheet from a prior calculation, right? And you'll notice there are all these different formulas, and in this case there's that QN number, which is in green, and it's going to run through a whole bunch of calculations and then spit out this end plates variable, which is in green as well, right? So technically what we want to do in this case for this particular model is it's going to pull in a QIN from Creo. It's going to then run through all the calculations, get to a number for what end plates should be, and then pass that number back to Creo Parametric. So Creo can then set the number of plates to however many Mathcad calculates it to be, right? Now, in order to do that, we're going to essentially designate within Mathcad what are input and output regions for the document, right? So in this case, for example, with the end plates, now we're designating that that is going to be an output region. And in the input-output designation there, we're giving it an alias called end plates. So that way, when it passes the information to Creo, it's going to call it end plates. It's not just going to call it out, and then it's sort of a meaningless parameter at that point. And so, yeah, we designated the output to end plates, and now we just designated the input as that QIN field. So that way, Mathcad knows to pull it in. And then finally, we're going to go save and push, right? And that save and push then, again, saves the Mathcad document and then pushes those variables to Creo. So that way, Creo can receive that information. All right, so now we're in our Creo model here, and we're going to start incorporating those parameters that we were just creating inside of Mathcad. All right, so you'll notice down here, there's that Q in, and the source is an input from Mathcad, right? And the value is 430. And so again, that shows that, whatever we're getting from Mathcad, it's passing that information in to Creo, right? And then Creo is then going to do some, we can then use that in here with the relations to assign it to different variables within Creo. And likewise, you can also then pass data out to Creo as well. Right? All right, sorry, pass data out to Mathcad as well. All right, so in this example here, there's a QIn parameter that existed in Mathcad, and there's also the QIn that already existed from within Creo, and now we're just equating them to each other. So we're saying, hey, let's take the input torque from Creo and pass that in to Mathcad, so that way Mathcad can start running its calculations. And so that's that first line in the relations editor box that you can see right there. And now we're going to do the same for the output as well. Now we're going to say, let's take the number of plates parameter, which exists as an integer in Creo, and let's equate that to the end plates parameter from Mathcad. So that way when Mathcad spits out the end plates value, it's just going to equate that to the number of plates parameter that already exists in Creo. All right, so we just equated both of those parameters together. I verified the relations, and now you'll notice there's a yellow flag at the bottom there where it says the Mathcad document is outdated, right? And so now that means, it's passed in something to Mathcad, and now Mathcad needs to recalculate, right? You'll notice now the input torque is 670, right? Not 430 like Mathcad initially mentioned. And you'll notice there's that, what's it called? There's that Mathcad glyph at the top right corner of the graphics window. If you click on that, that will immediately open up the Mathcad worksheet that's already embedded in the model. And again, that's your clue to know that, okay, there is a Mathcad document embedded with this Creo model, right? And so now that we're back in Mathcad here, you'll notice the QIn field over there still says 430. And so now we're going to go, at the top in the ribbon there, update the input values. And now Mathcad is then going to realize, okay, now that we have the updated values, I should be using 670 instead of 430. And then I'm going to run through all the calculations, and I should have a different number for the end plates, or the number of plates at the end. Yep. And in this case here, it says, okay, for torque of 670, we're going to add 2 more plates to make that 6 total. And then now you're then going to pass this number back to Creo using, again, the save and push, right? So it pushes back the end plates to Creo. And now that we're in Creo here, you'll notice the regeneration manager is yellow, which means, something has changed. I need to regenerate. And whenever we go ahead and regenerate, or hit Control G to do that, it's going to increase the number of disks. And now we'll just zoom in a little closer, so that way you can see as it goes on. You'll notice there are currently 4 blue disks. We regenerate, and now there's 6 of them, right? And so again, that just goes to show the power of Mathcad with Creo in order to combine both of those together and perform, analysis-driven design. Right? All right, so that's going to be it for our live demo today. We're going to go ahead and take some questions at this point. So if you have any questions, again, you can type them in the questions pane of the GoToWebinar control panel. But I'll just go ahead and start answering, one of these that we already have in here, which, typically speaks to some of the more common questions we get are, what when was this functionality introduced into Creo and Mathcad, and what versions is it available for? This functionality has been around for a few years, probably about 3-4 years or so. I think the first version that had it was Creo Parametric 3.0. And again, just for reference, Creo 5 just got released about 2 months ago or so. And so Creo 3, 4, and 5 are able to use the Mathcad integration feature, and also Mathcad Prime 3, Mathcad Prime 3.1, and also Mathcad Prime 4 are the versions of Mathcad that can use this particular integration feature to pass data back and forth from Creo to Mathcad. Yeah, so those are the different versions that can use it. In that particular example that we had, I believe that was Creo 3 and Mathcad Prime 3.1. Again, just to show you that it's been around since then, but Creo 4, Creo 5 will be able to do it just fine, and likewise Mathcad Prime 3, 3.1, and 4. All right. Another question is, do you have to purchase a license of Mathcad in order to have access to that integration feature? And technically, the answer is no. And so, really, what happens is, with every purchase, I believe, of Creo 3, 4, 5, the installer will typically come with an installation of Mathcad. And Mathcad is, so essentially when you install it without a full license, what you're installing is Mathcad Express, right? And so there's a certain amount of functionality that's available for you to accomplish with the Mathcad Express, and there are other advanced functions and formulas that are not available unless you purchase a full license. And so with the baby Mathcad Express version, you can still integrate those worksheets into Creo, and you can still start to document some things and use that even without a full Mathcad license. All right. Another question that came in here says, can you drive the design of individual components of an assembly from a Mathcad worksheet that's embedded in the assembly? Yeah, and the answer to that is an absolute yes. Absolute yes. In this particular example, we were using Mathcad to drive a parameter called endplates, and we patterned that parameter and used endplates as the value for that pattern for the number of plates in there. But we could just as well, if that example included changing the diameter or the size of the disks, we could just as well have taken an output which would have been a diameter, for example, and then pass that in to the diameter of the disk within Creo. And so in that case, instead of equating it to a parameter, we would go look for the would go look for the dimension of that particular feature from the part within the assembly, and then we'll equate that dimension. So I don't know, for example, if it's a sketch dimension, SD5 or something, if you're within Sketcher, or outside of Sketcher, it's going to be some dimension number and then coupled with the feature ID. And you'd equate that with the Mathcad variable, and Mathcad would be able to drive that as well. So you can use it on dimensions and also parameters. All right, looks like the question stream is dried up here, so we'll go ahead and close the webinar. Again, we hope that this is informative for you. If you have any further questions about this particular feature in Mathcad, my contact information is up on the screen. You can send me an email or give our office a call, and I'll be more than happy to assist you in any way I can with getting Mathcad and Creo integration working properly. Again, thank you so much for your time this Wednesday, and we hope to see you on a future edition of Boundaries Webinar Wednesdays. Thank you so much. Bye.